Quadratics, the quadratic formula, the discriminant, and the sum and product of the solutions. For this, the sum and the product of the solutions, that's going to be your new thing. You've done the quadratic formula before, and you've seen the discriminant. You may or may not understand exactly what it's used for, but that's fairly basic. Let's get started. First, the sum and product of solutions of a quadratic equation. If S1 and S2 are solutions, that means x-intercepts, of a quadratic equation of the form ax squared plus bx plus c, then the sum of the solutions is equal to negative b over a, and the product is equal to c over a. You need to know this. As we go through it, you can memorize it, rebuild it, whichever works best for you. Okay, so if the solutions of a quadratic equation are S1 and S2, then what we can do is if we've got ax squared plus bx plus c, we divide the entire equation by a. Now notice I have b over a here. Well, I have b over a, but it's negative b over a, so that's why I have minus the sum. I have c over a. That's plus the product. So it's x squared minus the sum x plus the product is equal to 0. That's it. So if I want to write the quadratic equation that has real solutions 4 and negative 5, that means that it crosses the x-intercept at 4 and negative 5. Then I do x squared minus the sum of the solutions, 4 plus negative 5, x, plus the product, 4 times negative 5. That becomes x squared minus negative 1x plus negative 20. Simplified, x squared plus x minus 20. It's not hard, but you do need to do the practice so that when you see it on a test or quiz, you know what you're doing. This requires studying and practice, not a lot of thinking. So here's example 2. Write the equation that has real solutions 7 and negative 3. Pause the video and see if you can do it. You're back. Good. Well, let's first put the sum of the solutions in and the product of the solutions. Let's evaluate the sum and let's evaluate the product, and then let's simplify it. And when I say simplify it, I mean get rid of double signs like over here, plus and minus. That's just minus. Okay? Everybody get x squared minus 4x minus 21? Yeah, good job. Let's go to the next one. The quadratic formula. Oh, and the other you've got to be able to do, look at the problems. The quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Ah, yes, the quadratic formula. Well, this is how it came about. It's from completing the square. Given ax squared plus bx plus c equals 0. Our first step is to move the constant to the opposite side. Remember that we want to complete the square. Now we need the coefficient of x squared to be 1, so we're going to divide the entire equation through by a. Next, we're going to complete the square. Completing the square means 1/2 of the middle term, which is b over a, and we're going to take that quantity and square it. That gives me b squared over 4a squared. That's where that came from. Now, I'm going to write the trinomial as a binomial product and simplify. Basically, this is a perfect square trinomial. Over here, I need a like denominator. So I need to multiply the top and the bottom by 4a. Okay, so I need my like denominator. That's where the 4a over 4a comes from. Now I have negative 4ac over 4a squared plus b squared over 4a squared. Common denominator. I can now make the top here minus 4ac plus b squared all over 4a squared. Remember, I don't add my denominators together when I'm adding fractions. Finally, I square root both sides. Now down here, notice what I did. I used the commutative property and I took the plus b squared and I moved it in front. That way I got b squared minus 4ac. Looking familiar. I have 4a squared in the denominator. I can't have a radical in the denominator, but it's okay. Square root of 4a squared is just 2a. And then if I subtract the b over 2a from both sides, and again, this part right here is 2a, because the square root of 4a squared is 2a, I have the quadratic formula. It was derived by completing the square. An example of using the quadratic formula. I have x equals negative b plus or minus the square root of b squared minus 4ac. I have my quadratic. I identify a, b, and c. In this case, a is 2, b is 3, and c is negative 20. I'm going to plug everything in. So I get x is equal to negative 3 plus or minus the square root of 9, that's 3 squared, minus 4 times 2 times negative 20 all over 2 times 2. I simplify things. I'm going to simplify the value underneath the radical. You have the radical, and underneath the radical is what we call the discriminant. We're going to talk about what that does for us in a few minutes. But suffice it to say right now that you're going to simplify the discriminant. In this case, the discriminant is a perfect square, so I can take the square root of 169, and that's 13. Now I have negative 3 plus 13 divided by 4, and negative 3 minus 13 divided by 4, which gives me a final answer of 5/2, or negative 4. These are the two real rational roots. They're rational. They can be written as a ratio of integers, 5 to 2, negative 4 to 1. They cross the x-axis in two real locations, 5/2 and negative 4, 5/2 0 and negative 4 0. The quadratic formula helps you to solve a quadratic that is in standard form, where ax squared plus bx plus c is equal to 0, and a does not equal 0. If a equals 0, then you've got a line. The plus or minus in the formula indicates that there are two solutions, one in which the terms in the numerator are added and another in which the terms are subtracted. To help you remember the quadratic formula, you can use Mary Had a Little Lamb. You will only hear this once. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. That can help you to remember it, or can make you wish you had never heard that before. Now, let's continue. If we have 6x squared minus x minus 2, again, we need to write in each one of the values as they appear here. You should be very adept at identifying a, b, and c. Once you have a, b, and c identified, you can go through and fill in all of the blanks. Okay, thinking end. And then at this point, it's a matter of evaluating. So negative and negative 1 is 1, plus or minus the square root. I have 1 minus a negative, minus a negative. 24 and 2 is 48, all over 12. This is 1 plus or minus 7 over 12. Where did the 7 come from? 1 plus 48 is 49. Square root of 49 is 7. I now have 1 plus 7 is 8 over 12, or 2/3. 1 minus 7 is negative 6 over 12 is negative 1/2. Again, two real, rational solutions. These are two very easily identifiable locations on the x-axis where this parabola, which opens up and has a vertical stretch of 6, will cross the x-axis. Now you try solving one. Pause the video and see if you got it right. Welcome back. For sake of not having to change the colors. Okay. 21. Oops. Okay. All right, now I have negative 20 plus or minus the square root of 316 over 6. 316 is not a perfect square, but I can simplify the radical. Okay, the same thing as negative 20 plus or minus the square root of 4 times the square root of 79. 316 is divisible by 4, goes into it 79 times, over 6. Continuing on, we get negative 20 plus or minus 2 root 79 over 6. 2 will go into 6 3 times, into a negative 20, negative 10 times, and into 2 once. This gives me a final answer of negative 10 plus or minus 6 square root of 79 all over 3. I don't need to simplify it anymore. While 3 can go into 6, it doesn't go into 10. So it really doesn't help me to take it down any farther. Okay, one more. But here's a tricky thing. Before I do this, I need to have it equal to 0. So that means I need negative 2x squared plus x plus 1 is equal to 0. Now I can identify a as negative 2. I can identify b as positive 1. And I can identify c as positive 1. Now I can go through and get negative 1 plus or minus the square root 1 plus 8 minus a minus all over negative 4. This is equal to 9. The square root of 9 is 3. So I have negative 1 plus 3 over negative 4. And I have negative 1 minus 3 over negative 4. Negative 4 over negative 4 is 1. 2 over negative 4 is negative 1/2. There are the two answers. I can also check this by graphing. I can throw it into the graphing calculator, and then I can actually change my window. I press y equals, I put my equation in, remember it has to be solved for 0. Then I can go to my window. I know what I got as my solutions, so I'm going to make my x minimum and my x maximum small values so I can zoom in, and my y min and y max, y min, y max, small values, and then I push the graph button, and I can identify -1/2 and 1 as my x-intercepts, my roots, my zeros, my solutions. The discriminant. The discriminant is the name given to the expression that appears under the radical, square root, and the sign in the quadratic formula. It is just the b squared minus 4ac, no radical. The discriminant tells us about the nature of the roots of a quadratic equation, given that a, b, and c are rational numbers. It quickly tells you the number of real roots, or in other words, the number of x-intercepts associated with a quadratic. How does it do it? Well, let's take a look. There are 3 situations. When the discriminant b squared minus 4ac is positive. In this case, the discriminant is 16. The discriminant is equal to positive 16. This tells me that there are 2 real roots. And because it's a perfect square, I have 2 real rational roots. They're rational because I can write them as a ratio of integers, plus -5 and -1. The second situation, d is equal to 0. Well, if my discriminant is equal to 0, as it is here, it doesn't matter if I add it or subtract it. It doesn't change. I have x equals 1 and x equals 1. I have 1 real rational root, and it also happens to be the vertex. If you only have 1 root, then that root is the vertex. It's a turning point. We call this multiplicity of 2. Anytime you have a root that occurs twice, like this one, it's a turning point. Notice the parabola comes down, touches, and turns around. Turning point. Finally, what happens when it's negative? Well, I have the square root of -31. Right now, you can't do that. When we get to Unit 5, you'll find out that these are, in fact, the answers. We have imaginary answers. Right now, you would simply say that you have 2 complex or imaginary roots. Okay? These are not real. They're not real x-intercepts. There are no real x-intercepts, no real solutions. There are 2 complex or imaginary solutions or roots. When you answer quizzes and tests, when the discriminant is negative, which in this case, the discriminant is equal to -31. Notice there's no radical. I have 2 complex or imaginary roots. No real solutions. Take a moment and determine the number of real solutions based on the discriminant, and then find them. Oops. Get that all the way up. Were you successful? How about this one? Now notice the discriminant. I don't have a radical. I'm not asking you. I'm just saying, what is b squared minus 4ac? 2 imaginary roots. Here we found them. You don't need to find these yet. A couple of weeks, you'll be finding them. Right now, This is where we stop. This is where we're going. Finally, this one real rational solution, and your one real rational solution is -3. When I add or subtract 0 to -6, I still have -6 divided by 2 is -3. Good job. Again, discriminant. If all I ask you for is the discriminant and the number of solutions, you stop up here. This is all you're being asked for. If I ask you for the actual solutions, then you need to come and follow through down here. Okay? Summary: the quadratic formula is another method that can be used to solve a quadratic equation, also known as finding the roots, the solutions, the zeros, the x-intercepts of quadratic equations. The quadratic formula is particularly useful when a quadratic expression is not factorable over the set of integers. Oh, not Mary Had a Little Lamb. Sorry, Pop Goes the Weasel. Shows you how musical I am. You can sing the quadratic formula to the tune of Pop Goes the Weasel. And that's the part where it was x equals -b plus or minus the square root b squared minus 4ac all over 2a. Yeah, I told you you wouldn't hear that again, but now you did. The discriminant is the portion of the quadratic formula under the radical. It indicates the number and the nature of solutions. When the discriminant is positive, you have two real solutions. If d is a perfect square, then the solutions are rational. If d is not a perfect square, the solutions are irrational. If the discriminant is less than 0, you have two imaginary solutions, or no real solutions, but two imaginary ones. And when it's 0, you have one real solution. Great job, great work. Try your homework. Let me know how you did.